Welcome to a lesson with Dr. Powell. Let's take a look at how to figure out how many possible negative x-intercepts there are using Descartes' rule of signs. So let's think about that for a minute. We have f of x is equal to, let's suppose we have x to the 7th plus x to the 5th plus x minus 1. Okay, so right now, taking a look at this, it looks like we have, at least for positives, we have one sign change. So actually, we're guaranteed one positive x-intercept. But what about negative? Well, to get the negatives, all we do is so let's think about this graph. There's going to be, what we did was we just investigated this part of the graph over here. But there's another part of the graph over here. How do we investigate this? Well, why don't we just reflect this to the other side and do the same analysis? How do you reflect this to the other side? You've just replaced all your x's with negative x. That reflects. So if we take a look at putting negative x's in for x everywhere, making the slots, and then inserting negative x, and then maybe simplifying. Here with the 7th power, the negative comes out. Here with the 5th power, the negative comes out. And then the negative. Okay, then we look at this and we say, we just reflected this over. So what was negative in this graph is now over here. So then we do the same analysis and we count signs. I don't see any sign changes, which means that there are 0 negative x-intercepts for sure. So we know for sure there are no negative x-intercepts and there's one positive x-intercept in this case. Let's look at another example. Suppose, for instance, that we have g of x is equal to x to the 6th plus 5x to the 5th plus 4x cubed plus x squared, and then we do minus 2. So let's take a look at this. Positives, again, we know there's exactly 1 because there's one sign change, and going less a multiple of 2, that's the only option. So we know for sure there's one positive x-intercept. Now, if we want to investigate how many x-intercepts there are that can be negative, we simply reflect this by replacing all our x's with negative x. So we take a look at g of negative x and we see, okay, negative x, we make slots here everywhere where we're going to be inputting it. And we put in negative x in, negative x, negative x. When we say an even power, it gets rid of that negative. So we can just think of that. If it's odd, the negative is preserved outside. And we take a look at this. Okay, we count the sign changes as we go. Okay, here we have 1 sign change, no sign change, 2 sign change, and 3 sign change. Okay, so we have 3 sign changes, which mean there are either 3 or 1 negative x-intercepts. So looking down here, just making sure, yep. So because we went down by an even number from here, and that's the only option that would take us down to an even number here. So hence, if we're searching for solutions or zeros, x-intercepts of this polynomial, this gives us some vital information. We know we have one positive x-intercept, and here we actually know we have at least one negative x-intercept because we have 3, we definitely have 1, and then the other option is 1. So we at least have 1 of each. Thanks for watching.